we look at the function quantity x minus 3 times x squared minus 5x minus 6 times x squared plus 2x plus 20. What we want to do is we want to see if we can find, see if we can graph this function. So if we can find its zeros, its y-intercept, its far right and far left behavior. We see that this is a polynomial function. In fact, we see that it's a polynomial function of degree 5 because if we multiply out the highest power of x, the highest powers of x from each of the factors, we get x to the fifth. It's clear then if we use a distributive law step by step to multiply this out, we will get x to the fifth as the leading term, so this is going to be a fifth degree polynomial. Now we've got a couple of quadratic factors here, and we have to check those to see if either one of them is reducible, okay, or irreducible. This one here, we can just look at this and factor it. Okay, we have x minus 6 times x plus 1. X squared minus 5x minus 6 is x minus 6 times x plus 1. Of course, we keep the linear factor x minus 3. So what looked like it might have a linear and two irreducible quadratic factors, in fact, turns out to have three linear factors. Now, this quadratic factor is irreducible. Under the square root sign, we're going to have negative 2 squared minus 4 times 1 times 20. That's going to be 4 minus 80, or negative 76. So we're not going to have any zeros from this, and if we don't have any zeros, it's not going to be factorable or reducible. Okay? Now let's look at that assertion just a little bit, just a little more in detail before we go on. Okay? First of all, if we applied the quadratic formula to x squared minus 5x minus 6, which we know factors, we would end up with what we show here. And we'd end up with solution 6 or negative 1. Those are the zeros that we get from x minus 6 and x plus 1, so that x minus 6 and x plus 1 are the factors of x squared minus 5x minus 6. And of course that's what we found over here. The lesson here is that if we find two zeros, then we can factor the original polynomial as x minus the first times x minus the second. X minus negative 1 would be x plus 1. This is true even if you have really ugly looking zeros, complex numbers and so forth, or at least numbers with radicals. I guess we're not talking at this point about complex numbers. But you see that this is what we get. X minus 6 times x plus 1, x minus this 0, x minus this 0, giving us x plus 1. Okay. Again now, if we go to the quadratic formula, we don't get any solutions, which means this can never be 0. If we could factor it, it would have zeros. Since it doesn't have zeros, we can't factor it. That's the logic of the situation. You want to think about that, make sure that's very clear to you. So we do end up with 3 linear and 1 irreducible quadratic factors. From this, we can easily write down our zeros. They're 3, 6, and negative 1. Those will make these 3 factors 0. The y-intercept, where x equals 0, we simply substitute x equals 0 into any of these forms. The first is probably the simplest. We're going to have negative 3 times negative 6 times 20, which is 360. Not sure why I wrote the 1 down there. Yeah, I do. I was looking back here to get the the factors, but it would have been easier to look back here to get the y-intercept. Anyhow, the far left behavior, for large negative x, we get a large negative y, a really large negative y. Why is this? Because these 3 factors will always be negative if x is a large negative number. As long as x is, less than negative 1, these are all going to be negative. This, on the other hand, for large negative values will be positive because the x squared will dominate the rest of the terms, and it's always positive. So large negative gives us large negative y, and large positive x gives us a large positive y, because clearly everything here is going to be positive if x is a very large positive number. Using this information, we can easily draw the graph. We first sketch our zeros at negative 1, 3, and 6. We sketch our y-intercept. We indicate our far left behavior and our far right behavior, and everything just falls into place.